Hello dear students. In today's lecture, we will discuss the properties of fuzzy sets, and then finally we will discuss a very good example which will demonstrate us the various operations which we can perform with the fuzzy set and its implementation also. So as you have already know that we have discussed the concept of fuzzy set logic, the concept of fuzzy set, fuzzy statement, crisp statement, some properties of the classical sets, properties of the fuzzy sets. I'm just coming to this point. So there are a lot of properties which we have already seen in the classical sets. They all exist for the fuzzy sets also. But there's some contradiction also. There are some properties like we have seen that the law of excluded middle and the law of contradiction in the crisp set, they do not fulfill fuzzy sets. Like here we are saying that union of two complements, union of A and its complement is not the complete universe of discourse. It was happening with the classical set, but it does not exist for the fuzzy set. Here what I'm saying that, say for example, A is a fuzzy set, its complement is also a fuzzy set, and I'm making the union of these two. It will not be the universe of discourse, right? Similarly, what I'm saying that suppose we are having a fuzzy set and another is the its complement fuzzy set, and we simply want to make the intersection of these two sets, so we will not find the null set as we were finding it in the classical set. Here in fuzzy set the situation is not like that. Here union of these two complement sets to each other is not the universe of discourse, and the intersection of the sets which are complement to each other is not the null set. This is the only difference, which is the only property which does not exist for the fuzzy set. Rest all the properties we will see later on how they will work for fuzzy set, right? Okay, so now the first property is the property of commutativity. According to this property, suppose we are having two fuzzy set A and fuzzy set B. The union of these two fuzzy set, once we make the union of these two fuzzy set, either we are doing A union B or B union A, both will be the same thing. There is no difference. If we are making the intersection of two fuzzy set, so if we are doing A intersection B or B intersection A, they will be the same. As you have already seen here, A is having fuzzy set A is having all the elements of the universe of discourse. B is also having all the elements of the universe of discourse. But in A, elements are having different kind of membership value. In fuzzy set B, elements may have different kind of membership value. And once we are making the union of these two sets, the membership value will change, and at that time membership value will choose the highest membership value among these two sets in the union set. And similarly we have seen when we are doing the intersection of the two fuzzy sets, the membership value in the final resultant set will be the minimum membership value among set A and set B. So by this way we have done all these things. Now comes on the associativity property. I already told you, once we are doing with the associative property, then we have to make the same sign of the operation. A union B union C is same as the A union B then union C, or we may change the operations also. If intersection is here, so intersection must be there in the bracket also. So A intersection B intersection C would also be equal to the A intersection B, and its resultant is then intersected by fuzzy set C. So it also holds for the fuzzy set. Now comes on the distributivity. It also holds for the fuzzy set. For the distributive property, we have to take both the operation union as well as intersection. So A union B intersection C is equal to A union B intersection of A union C, and here also, right? Now come on the idempotency property of the fuzzy set. It says that A union A must be equal to A and A intersection A must be equal to A. Now here we are talking about the fuzzy sets. Identity property says that if we make the union of the null set, if we are making the union of null set with any fuzzy set, resultant will be the same fuzzy set. Or we are making the union of any fuzzy set with the universe of discourse, we will find the complete universe of discourse, right? If we are making the intersection of one fuzzy set with a null set, we will find the null set. If we are making the intersection of a fuzzy set with the universe of discourse, then we will find the same fuzzy set. Next property is the involution property, as it already holds for the classical set. Same way here, it is also applicable for fuzzy set system, fuzzy set logic. Here, complement of complement is the same fuzzy set. Transitivity is same. If A fuzzy set is a proper, A fuzzy set is a subset of B fuzzy set, and B fuzzy set is a subset of C fuzzy set, then A is subset of C fuzzy set. Then the De Morgan's law also holds for the fuzzy set, where the complement of the union of A and B fuzzy set will be the intersection of A's complement and B's complement of the fuzzy sets. Similarly, we can say that the complement of the intersection of two fuzzy sets will be the union of the complements, union of their complements, right? So here we are seeing that all the properties which were applicable to the classical set, they are also applicable to the fuzzy set, except the law of excluded middle and the law of contradiction, right? Now I'm just showing you a very beautiful example which will help us to visualize all the concepts which we have learned in the previous lectures. We have learned the union operation, intersection operation, complement operation, De Morgan's law, all these operations we have seen. Here the beauty of fuzzy system is, fuzzy logic is that whenever we are making the union, it will have all the elements. Whenever we will have the intersection, it will have all the elements, right? So here a universal set is given to us, and that universal set contains all the different variety of military aircrafts. Say for example, variety of military aircrafts are there with our military, with our air force, right? And say they are some A-10 planes are there, aircrafts are there, B-52 aircrafts are there, C-130 aircrafts are there, F-2 aircrafts are there, and F-9 aircrafts are there. Say for example, in our air force, there are 5 different varieties of aircrafts which are available, right? So here I make the universe of discourse which contains all different type of elements. So these are the 5 elements which we see that they are available with the air force. There are 5 different variety of aircraft. Now each and every aircraft is having different type of characteristic. Now on the basis of the different characteristic, and on the basis of these characteristics, we want to classify them into different classes. So let us suppose that there is a fuzzy set A, and this fuzzy set A is a bomber class aircraft. Now so say for example, I ask you to make a fuzzy set A, and this fuzzy set A is representing to the bomber class aircraft, which is having the characteristic of bombing characteristic. So here in this universe of discourse, all the aircrafts are having some bombing facility, but there are some specific aircrafts which are specially designed for the bombing purpose. There may be some aircraft which are specially designed for the fighter purpose. There are some aircraft which are designed to take off with some load for carrying for logistic purpose. So variety of aircrafts are there, and they all the aircrafts are having different kind of characteristics. So I asked somebody to make a fuzzy sat which will fuzzy set of the bomber class. So now according to the perception of that person, what he did, he make aircraft A10, and according to his perception, he think that it fits in the category in the class of the bomber fighters with point 0.3. As I already told you that the membership value of each and every element must be in a range of 0 to 1, and it represents the degree of association of that specific element with respect to that fuzzy set. Now, according to the perception of the person who I have assigned a task to make the fuzzy set, according to his perception, he thinks that B10 aircraft is having zero point 0.3 membership value with respect to the bomber class aircraft. And according to his perception, B52 is more suitable. According to his perception, he thinks that B52 is having more characteristic in terms of bomber class, and C130 is having very less characteristic for bombing property. F2 is having another very less property, and according to his perception, he felt that F9 is the most suitable aircraft for the bombing facility. That is why he put here membership value 1 along with F9 aircraft. So now here one fuzzy set A has been designed by some specific person. If I ask this job to perform to somebody else, he may design a different kind of the fuzzy set having all these elements, but with the different membership values. So it also depends on the perception of individual. Here the vagueness comes in the picture, right? Accordingly, now I ask the same person to make a fuzzy set of fighter class aircraft. So according to his perception, he thinks that the A10 aircraft is having 0.1 membership value in the fighter class aircraft, in the context of the fighter class aircraft. B52 is having 0.2. C130, he feels that C130 is most suitable for the fighter class category. There may be some specific characteristic of each and every aircraft. For fighting purpose, there can be some standard characteristic. For bombing purpose, some another characteristic. For logistic purpose, some another characteristics may be there. So according to his perception, he felt that C130 is the most suitable aircraft which can perform the task of the fighter plane. So accordingly, he marked here as 0.8, but here the membership value is 0.8, not the 1, because as per the perception of the person who is making this fuzzy set, there are some other properties also which should be there in the C130 aircraft in terms of the fighter aircraft, right? And accordingly, F2, the membership value is assigned as 0.9, and F9 is membership value is 0. So it means according to the perception of the person who is making the fuzzy set P, he felt that F9 is not at all a fighter plane. According to his perception, F9 is only the bomber aircraft, right? Now, what is our task? We are asked to make different fuzzy operations. What is given to us? We are having a universe of discourse. We are having two fuzzy sets. Now we are asked to perform the union operation of these two fuzzy sets, the intersection operation of the fuzzy set, finding the complement of A fuzzy set, finding the complement of B fuzzy set, then here the finding of A union B and making its complement, and lot of other operations are there which are asked to be performed. Now let us start one by one each and every operation. First of all, let me give you a recap of the previous lecture when we are asked to make the union of two fuzzy sets. So again I am telling you one very important thing: both the sets will have the all elements of the universe of discourse. And when we make the union, again the union will have all the elements of the universe of discourse. But here the membership value will be different. And what will be the membership value in the union function? In the union set, it will be the we will choose the maximum membership value of each element, either from set A or from set B. So here you see, when we are making the union of A and B, A10, B52, C130, F2 and F9, they all will be available in the union set. All these elements will be available in the union set. But with what membership value? Membership value will be the maximum value among the given fuzzy set. Now see here, A10 is having 0.3 membership value in A fuzzy set. A10 is having membership value 0.1 in B fuzzy set. So the bigger membership value is 0.3. So in the union, we will make the 0.3 membership value of A10 fighter, A10 aircraft. Now we are talking about the second element, which is the B52 aircraft. And for this aircraft, its membership value was 0.2 for B fuzzy set and 0.4 for A fuzzy set. 0.4 is the higher side value, so we will keep this higher side value in the union set. Now for C130 aircraft, it was having 0.2 membership value in set A and 0.8 membership value in set B, so we will keep the higher value, that is 0.8 will be here. Similarly 0.7 will come here, and for F9, one membership value was in A, membership value was 1, in B set, fuzzy set B, membership value is 0, so take the higher one and we will mark here 1. So here what we did, we make the union of two fuzzy sets, and this union contains all the elements of the universe of discourse with the membership value, and the membership value will be the maximum value among the given fuzzy sets, right? Now come on the second point. We are doing the intersection of the two fuzzy sets. In the intersection purpose, in the intersection operation, we will again keep all the elements of the universe of discourse, but with a different membership value. Here the membership value will be the minimum membership value among these two sets. See here, A10, B52, C130, F2 and F9, they all aircraft will be available in the intersection function. Yes, its intersection will again be a fuzzy set. This again will be a fuzzy set. So all elements are there in the fuzzy set with the membership value. Now the membership value will be the minimum among them. The minimum among them is 0.1, then minimum 0.4 and 0.2 is 0.2, then 0.2 and 0.8 is 0.2, 0.1, 0.7 is 0.1, and 1 and 0 minimum is 0. So by this way we make the intersection of the two fuzzy sets and we find out the membership value of all the elements, right? Now come on the third thing which is asked to done, that is we are asked to make the complement of a fuzzy set. Again I'm just telling you that the union of one fuzzy set with its complement fuzzy set is not the universe of discourse, right? So what is here? The complement of a fuzzy set will again have the all those elements which is available in A. This is the beauty of the fuzzy set theory. The complement of a fuzzy set will again have all those elements which are available in A set. See here what is happening. A is a fuzzy set which is having 5 elements: A10, B52, C130, F2 and F9. So they all will available with the complement fuzzy set also. They all will available in the complement fuzzy set also, right? But here the membership value will be different. the membership value will be 1 minus the membership value which was there in the given fuzzy set. So here the membership value of A10 will be 1 minus 0.3. The membership value of B52 will be 1 minus 0.04. Membership value of C130 will be 1 minus 0.2. For F2, the membership value will be 0.9. For F9, membership value will be 0. So by this way, we make the complement of a fuzzy set. It will again be a fuzzy set, right? Now I'm coming on a thing. A here, this is the pipe symbol, and A fuzzy set, pipe symbol, B fuzzy set. What does it mean? It is the intersection. It is the intersection of A and B's complement. It is the intersection of A and B's complement. And for the intersection purpose, we choose the minimum one. And for the B's complement, we choose 1 minus mu B. So see here what is happening. We are making a fuzzy set which will have all the elements of the universe of discourse, but the membership value will be found by this rule. Finally, we are making the intersection, and intersection can be achieved with the help of the minimum operation. So we apply here minimum. For A, the membership value can be achieved by mu AX. For B's complement, membership value can be achieved by 1 minus mu BX. So see here, what we are doing here, we are finding the minimum value from mu AX and mu B complement X, right? So we apply this rule and we will make the final set. Similarly, we have done the question number F. Now from the point that we are asked to make the complement of the union of two fuzzy sets. First of all, we are making the union, and then finally we are making the complement of them, right? Complement, to achieve the complement, what we have to do, we have to find its membership value, which is done with the help of 1 minus something, right? For complement, say for example, we are saying to find out the complement of A. To find out the complement of A, it can be done with the help of 1 minus membership value of A, right? So now we are doing the G part of the question. We are asked to find out the complement of the union of two fuzzy sets. So first of all, our objective is to find the union. We have to perform the union operation of two fuzzy sets, and then we will find out its complement, right? In union, all elements will be there. In complement, all elements will be there. In A, all elements are there. In fuzzy set B, all elements are there. All means all elements from the universe of discourse. So in A, all aircrafts are there. In fuzzy B set, all aircrafts are there. And in A union B, all elements of the universe of discourse will be there, right? So how we can perform the union operation? For union operation, we take the membership value from the maximum, applying the maximum function, right? And once we want to make the complement of a fuzzy set, that can be done with the help of the 1 minus the membership value. So for union purpose, we are finding the value with the help of the max of mu AX or mu BX. Mu AX, A means here tilde sign is there, it is representing that A is a fuzzy set. This tilde sign is representing that B is a fuzzy set. Mu AX means membership value of X in fuzzy set A. This is mu BX, it means the membership value of element X in fuzzy set B. Among these two membership values, I am taking the maximum value, and that maximum value have been subtracted from 1. We apply this rule and we finally find this information. One another way to solve this problem was, what we can do there, we can find out the this entire information can be achieved with the help of the A's complement intersection B's complement. First we can find out the A's complement. First we will find out the A's complement of the A fuzzy set. and the complement of the B fuzzy set, and finally we can make the intersection of these two sides, right? Simply applying the De Morgan's theorem. So we know that De Morgan's theorem is applicable for fuzzy set systems also. So we here what we can do, we first of all we can apply the De Morgan's theorem, and according to De Morgan's theorem, its answer should be A's complement intersection B's complement. So here our objective will be, first of all we will find the membership values, the A's complement fuzzy set and the membership values of the B's complement fuzzy set, and that we can achieve 1 minus mu x or 1 minus mu bx. And once these two sets are ready, these two membership values have been achieved, then finally we have to make the intersection of these two sets, and for intersection purpose we have to take the minimum membership value among the two fuzzy sets. So we can apply that rule also, and by applying that rule we will get the similar type of fuzzy set, same value, same membership value we will get, right? So here you can see in the same way what we did here, intersection of A and B fuzzy set, and finally we are making the complement of them. In the same way you can do it also. And finally ith part and jth part, here you are asked to find out the A's complement union B's complement. Complement can be done, this is union, we are doing the union operation. For union operation, what is done here, max of mu complement mu A's complement x minus mu B's complement x, and this can be done with the help of 1 minus mu x, and it can be done with the help of the 1 minus mu bx. The same information you will get here. So there are variety of way by which you can perform all these kind of the different operations from fuzzy set. The important thing which is which keep to be remembered is that when we are doing union operation, complement operation, intersection operation, and the other variety of operation, every time we are getting all the elements in the fuzzy set which are available in the universe of discourse, right? The beauty is that suppose there are 10 elements in A's complement, so there must be 10 elements in the universe of discourse, and once we are making the complement of the A fuzzy set, so again there will be 10 elements, but the membership value will be different. So that's all in this lecture. In this lecture we discuss some properties of the which holds for the fuzzy set, and the variety of operations with the help of one practical example. In the next lecture we will discuss how classical relationship and fuzzy relationship are related to each other. First of all we will study that classical relationship, and then further we will conceive the same concept in the fuzzy relationship also. So that's all for this lecture. Thank you very much.